Okay. Hi, everybody. Welcome to the Diffusion Architecture channel. My name is Daniel, and today we are hosting KARLA SALDANA OCHOA. She's a tenured professor, tenure track assistant professor in the School of Architecture of the University of Florida, a faculty affiliate at the AI2 Center, a Center of Latin American Studies, and Fiverr. KARLA is a director of Shared Lab, a research group focused on developing projects that leverage the interaction between artificial intelligence and human intelligence, which is applied to boost creativity in architectural design and create tools to analyze big data of urban phenomena. She collaborates on international projects in Germany, Italy, Switzerland, Mexico, and Ecuador. She is also an Ecuadorian architect and coder with a Master of Advanced Studies in Landscape Architecture and a PhD in Technology and Architecture from ETH Zurich. Her PhD research the integration of artificial and human intelligence for an accurate and agile response to natural disasters, leveraging multimodal fusion approach for ML inference. Her topic is going to be about the intelligent environment, a protocol for AI data, and XR. KARLA, welcome. We're glad to have you here. I know you've been doing some pretty interesting stuff in architecture and AI. Recently, you hosted, or for the last 2 years, you hosted Plane Models, which combines like a wide combination of various researchers from around the world internationally, and they showcase some of their work. So that's really interesting, something that you come up together. Yeah, we're looking forward to seeing your research. I know you kind of mess around a little bit with the generative models, and you have also done like pretty interesting work related to how to extract patterns from data, right? From all sorts of data. And so the floor is yours. Welcome, and we're glad to have you here.
Well, thank you. Thank you, Daniel. I'm going to go ahead and share my screen so we can start with the short presentation, and then we can engage in this conversation that I'm very much looking forward. You have to enable share.
Oh, yeah, sorry about that. Okay, you should be able to go now.
Wonderful. All right. So I guess you're looking at my screen right now, correct?
Yeah, we can see it. Yeah.
Great.
Awesome.
So I'm going to talk today about creating a protocol for an intelligent environment. And this, as you've seen probably in one of my last lectures, I think it's an ongoing topic. It's not defined yet what an intelligent environment is. It's also a topic that started in the 2000s in computer vision and applied in games. But I want to think about this into the realm of architectural design and architectural world making. So as I said, I'm an assistant professor in the School of Architecture. And today this talk is going to be about creating intelligent environments and the interplay between human and machine intelligence in architectural practice. So first, I always like to talk very briefly about artificial intelligence. Now everybody has it in their minds and it's been written everywhere around. But I would like to talk about this being traced back to Alan Turing, who introduced this concept 70 years ago. So Turing proposed that machines can exhibit intelligent behavior by tricking people into thinking they are humans. Industry and academia have been competing to pass this Turing test with their AI systems for many years, and these competitions have led to a diverse toolkit of AI technologies that researchers, designers can choose from to achieve their projects, their design briefs, and so on. In this context, I want to think of AI as the act of designing and implementing algorithms that receive perception information from the environment, such as data, and they take actions that affect that environment, such as generating an image from a text input. So if we're thinking about AI in this sense, then it makes sense to frame it within this intelligent environment. What does intelligent means in this virtual environment that we're creating? If we look at also one of the first articles that try to categorize the different fields on artificial intelligence. This was a book by Stuart Russell and Peter Narvik in 1995, which was called Artificial Intelligence: A Modern Approach. They divided AI into 5 research areas that were based on these Turing tests. So there is machine learning, expert systems, computer vision, natural language processing, and robotics, and all of these were quite data specific, and they were for so long, or for many years, data modality specific. So we have computer vision for images, we have natural language processing for text, we have expert system, which was more about this regression and generation, for example. And then machine learning at the time, it was starting to become a strong field of research. But then what we see right now, this is 2024, we see that machine learning has overtaken all of these different AI research fields. So we see that not only all of these research areas are data specific, but they are becoming multimodal. So we have expert systems coming together with natural language processing. For example, this is the case of ChatGPT. We have computer vision coming together with robotics. This is the case of Boston Robotics, and we have DALI and expert system and computer vision, natural language processing. So this is a multimodal mash-up from many different research areas plus data to fed their algorithms. So I think this is interesting to think about now that we are living in an era where everything can become anything. How can we leverage this multimodality or multimodal data fusion approach into architectural practice? So if we look at the advancements of artificial intelligence today, we see that there's a lot of buzz on this world of generative algorithms and their applications and design processes. So last night I went into Twitter, X, and I tried to collect some of the outputs of people talking about AI and generation. So there is a deluge of images that have been automatically produced. And these images are created based on training data from the internet, curated databases. We have images from our smartphones. So there is enormous amount of data produced by ourselves and curated by ourselves that have been used to train these models. So I am talking about these generative algorithms that are the result of our data collection strategies. And these algorithms that they're trying to do, they're trying to encompass all the data points to generate something within a normally distributed curve. So for example, all of these images that we're seeing right now, they are all within these, let's say, the most recognized sense of what an image look like. And all of these examples can be considered within our imagination. So they are an interpolation of, yes, many thousands or millions of images, but they will always be within the boundaries that we can conceive. So these algorithms, as I said, learn from past data. So they know, right? They've seen and read everything in the web. But I'm curious to know what's happening in the curve, in the tail of this curve, because we know that all of these algorithms are learning to predict based on the most representative data from the data sets. But I'm curious to know what is happening here, what is happening in the tails, because they are, I think this is where these extraordinary designs that are defined or are trying to challenge this categorization from the normally distributed curve. And I think here we see exceptional shows of creativity. And to stress this idea, I want just to look at this article who were trying to understand creativity throughout time, and they created a rating. So they considered originality compared to prior work, and how valuable and how influenced the work was to future work. And what is interesting here very quickly is that a lot of the pieces or paintings that were considered to be creative, labeled by ourselves, were always those that were on the edges. So we're always the outliers. So this really gives us a very interesting take on how can we create something that is an outlier, a truly form of creativity, which is making us think, how can the machine alone can create creative work? So here's what I think. So in order to create a creative work, we should join with artificial intelligence and human intelligence, because I believe, and I think this is also in your, Daniel, in your mission statement on your website, is we think that AI can complement architects and designers to make informed decisions, generate new ideas, and explore design space that before were impossible. So I still believe I'm intrinsically positive about this sense. I want to also caution about the idea of leaving a lot of responsibility to AI. We have to try to find a balance where the interplay between our both bits of intelligence actually make a masterful output. So as I said, AI is powerful. It's also very versatile, and I think of it as it can be used as a tool or as an instrument. A tool similar to a hammer or a motor that is created for one specific purpose, and as an instrument like a violin or a piece of paper that it only creates something masterful or something meaningful once it's been enacted or enabled or used by a masterful human. So if you think about this, these AI as a tool or as an instrument allow us to communicate between different domains. What happened in architectural design right now? What you're seeing on screen is the representation of 20,000 scientific articles that were tagged as architectural design. The words on the bottom are the most common terms used in 2,000 articles about computational design. And what the cells that I highlighted are the cells that represent how often this word was used in all of the 20,000 articles. As you can see, the terms like system and model have been mostly used. And it makes sense because it started in 1990. Architects took some of the terms from cybernetics movement, and they started using these in media theory. And those terms have been introduced for more than 30 years, and they are kind of being merged into how we talk about architecture and computational design. But if you pay attention, words like AI, data, machine are less used. And this is because we are still in the very start or very early phases on this new paradigm of computation. And I think we could start thinking, working, and start trying to establish a new vector of work. I think the meaning of how we explore or how we will see this in the future can only be possible if we start playing, right? So I think the moment we start playing with these many ways of thinking, of including AI in different design processes or in different steps of the design processes, we could start creating knowledge, or we can start creating examples so people in the future could see what is and what is not a feasible or a direction to take on. So I think I propose to think as AI to being able to point to a particular direction, but we're the ones that decide whether this direction is where we want them, where we want us to take, where we want it to go. So I would like to start playing and exploring directions to take advantage of the state-of-the-art technologies to create new processes that can emerge through this close collaboration between humans and artificial intelligence, not considering AI as under control or under command, but as an active collaborator that is a player in this exploration. The idea that these technologies are used to augment human capabilities should also be to tune, they should be in tune with us. I would propose that let's use AI as an instrument. So it becomes this active collaborator and aids in our creative work. If we could utilize its capabilities to discover and to create. So let's go to AI and computation. Right? For many years, researchers have tried to develop these autonomous design tools capable of generating near optimal solutions. But here I always question is, how can we claim that this is something that is not going to replace architects if we don't have human intervention in the process? So these, let's say, the automated design tools are successful to solve some well-defined problems, but we actually know that architectural design is not a trivial problem. And it struggles to capture sometimes the creativity of the designers when you're trying to create an optimal tool or a tool to minimize or maximize specific criteria. So I want to show you quite quickly, like I will take like probably 2 minutes per project. I've developed kind of a timeline of several collaborations throughout the years into thinking about how to create a design, an agent active for design. So thinking of AI as an active collaborator on a design practice that started around 2019 with beyond typologies, beyond optimization. Then we work towards structural form finding through a text-based AI, text to 3D form in equilibrium, and then semantic test to space. So these are also going to be organized in the different typologies, because I think you cannot try to do everything at once, but it's interesting to just try to solve a specific problem at once. So we are going to talk about roofs, towers, bridges, and rooms. The first article, as I said, was started in 2019. I'll always try to have a QR code to an article so you could have a look later. So this is trying to grasp the amount of information that generative algorithms produce. So we know this is a mass production of solutions. So one of the main questions we have there is like, how do we actually arrive to the solution that fits the designer preference? So we propose a design framework that had 5 design operations, which could be used in a nonlinear interaction between machine and human. So you see a human in the center is our key or main effort here, but the way that you could choose different operations is up for how you want to generate, cluster, represent, and evaluate these forms. So as I said, here is something that is not predefined, but it allows for people or for designers to choose the sequence that they want. So if we look at this, we are working with Generation. So this is a collaboration with Pierluigi Diacuto, a professor at TU Munich and his lab. And as well, at the time, it was Ole Alberg. He was, I'm going to just go back to the initial slide so you can see their names. He's from ETH Zurich. We were the 3 of us at ETH Zurich, and as well Vahid Mojave. So we have Generation. We use the combinatorial equilibrium modeling. This is a method for the design of spatial networks in equilibrium that is based on graphic statics and a combination between tension and compression. We use quantitative evaluation and filtering. This is about defining these optimization functions to define what's the structural performance that we want to assure or be certain that it will have, and then this will help us filter out several structures already. We use an unsupervised clustering algorithm to visualize or represent the design space. And through this visualizing tool or this representative tool, we were able to create a training data that was based on the human perception or human preferences. And here was an initial, let's say, a empirical GAN architecture. So we were creating a generator and a discriminator, but this discriminator at that time was the human. So we were thinking about how will this GAN architecture could work as having a discriminator as actively selecting the preferences as it was generated. So with this idea of a empirical GAN, we created a tool that was able to generate based on the way that you select the design steps, several design options that at the very end turn out to be a design of a stadium room. But this is just one example of one designer. This could be any output depending on any interaction with any designer. So the second project is called Enhancing Structural Form Finding through Text-Based AI. And this is, we published this article in 2022. This was even before we had DALL-E available for everyone. So our question here is, how can we pair how can we pair text descriptions to a 3D form that is structurally stable? So at this time, we work with columns, and this is a collaboration with Guo Sifeng, Pierluigi Diacuto, and myself. And this also, as I said, with generative algorithms, you have enormous amount of data. So it's a mass production. And therefore, we needed to as well now think about how can we pair these text description with this form. So at the time we created a crawler that went online and collected descriptions of winning projects in architectural design competitions, and these descriptions were pre-processed in order to define specific adjectives that were used to describe those winning projects, and those adjectives were used to make the match. And if we go back to our design framework here, what we are looking at, the change was the way that we created the training data and the way that we encode the feature vectors to train the model. So as I said here, what we're looking at is not only a 3D model, but it's a 3D model that is structurally stable. And for us, this is one of the most important things, because when you are working with architects, you would like to have something that is feasible to be constructed. So in this time, we created an algorithm that was able to, and I'm going to show you how the training data was made of. So you will have using an unsupervised clustering algorithm, organize all the different structures in a way that is meaningful. So that you will have same structures in the same location. So you could start like popping up adjectives describing what this looks like. And then we use a GAN here to learn the relationship between the text embeddings to the input of the generator. And then once you have learned this correlation, once you write down the text, it will give you the input to generate such a structure. So by that, you were able to quickly write down some combination of words, and it will give you an output such this, which is the skeleton of a tower. And the interesting thing here is that you don't get only one example, but you get a family of examples that you can choose from. And if you put this into a design process, what you do is that if you start with a massing exercise, right? If you have a massing exercise that says, I think this is this like the scale, this width, and it's going to have these empty spaces and fill spaces, you could start fitting these geometry into these generative algorithms, so you can start creating some structural stable forms that can later be part of the design process, where you continue your current design strategies to end up having a fully stable structure, and you can look at how do you actually visualize these in different platforms. So this is how I used these generative algorithms within a design process. The next is still with text to 3D forms, but this is changing from, instead of a tower, a bridge. And the reasoning behind this is because a bridge has a specific typology. So a bridge can be hanging, arched, it can be a truss, it can be a beam. So you could really embed this into the generative algorithm itself. So what we're doing here, we're looking at the same algorithm, combinatorial equilibrium modeling, as the starting generative tool. And then we're using the same process as before with the towers by trying to create the training data that is pairing the text description plus specific typology information of the form and some structural stability metrics that later, if you see on the right, you'll see that the labeling is a much more complex than just words. It is a combination of different specific descriptions of the bridge itself. So this is a project also as well working with Pierluigi Diacuto, which is my dear friend. We worked in this line of research a lot, but here we're also working with Laszlo Blocker, his PhD, and Guo as well, Guo Sifeng. The idea with this is that you could write down a sentence, and this will give you you'll see now on the left, you're writing a sentence, and after you finish writing the sentence, you'll have several options that you can work with. The moment you get this output, you can say, oh, I don't like this one. You can modify the sentence and then get more examples. And then the process is that you use this output on Grasshopper, it gets infilled, so it gets volumetrized, and then you can work with creating a rendering out of that. So to have a fast idea exploration. And this is a project that a student from Pierluigi was developing, Tao. So if you're interested, I can send you all his work so he can explain it better than myself. The last project that I want to talk about is a project that I'm working with Jimmy Cheng. So he is the idea here is that we understand that in generative tools, you always have to regenerate everything again, right? But our question was like, what if we don't want to generate everything again, but we want to create a customized generation strategy, which means that we're not like, once you generate it once, you can start changing parts of the generation, similar to what you do when you're modeling in 3D, when you're modeling with bass wood. So for example, we took a design exercise here at University of Florida, which is called Door, Window, Stairs. And here the exploration is about how the scale, the size, the materiality, the openness, the closeness. And we developed a generative tool or generative algorithm that was creating these different elements organized in a different, based on different rules. So the idea here is that we want to be able to create a training data that is, oh my goodness, it's just passing without me telling it to stop. But here, let me do it this fast. So we asked the students to look at these models, and we asked them a question about which parts of this model you feel are complex. And they will look at the screen, and we will be tracing their eye gaze, and we will have both their eye gaze and then the way that they were selecting it with the mouse. And this will give us a overlapping one that is something that they do it meaningfully by looking at the cursor and the screen, and the other one is their gaze, which is much more let's say not planned. So the moment you overlap these two, you could have a kind of a very cohesive way of understanding what they think complex is. And in here, what is happening is that later we were able, by segmenting this model in specific parts, to assign that label to that part. And once we trained a unsupervised learning algorithm that will allow us to look at each of these parts. And based on a brute force search engine, we were able to modify parts of an existing building based on text prompts. So we could say, all right, we like this one form, but this section over here, I would like it to be like complex, or I would like it to be simple. I would like it to be larger, lighter. And then you will be reiterating the design process within one structure instead of having to all the time regenerate at once every time you want to change something. So this is where we're moving forward. It's still early in the stage, but I do believe this is something that is interesting. If you think about this as a Photoshop, the initial plugin of Photoshop that you're able to generate parts of an image, here you're able to regenerate from an existing structure or from an existing form specific sections depending on how you want this to be modified. All right, so as I said, I like to talk about tools and instruments, and I said that an AI as an instrument should be and can be able to complement the capabilities of architects. I show you very quickly some projects that we're using AI as an instrument, and I want to invite everybody that when designing, architects should balance novelty and familiarity. On the one hand, we desire for novelty, as it's been seen in the fields of fashion, but we also like what is familiar with. With the help of AI, we can find this balance between novelty and familiarity. The opportunity that AI brings to the profession is just beginning. As I said, is very, very recent. We still have many years to go. AI algorithms are valuable instruments, but as any other instrument, you must be skilled enough to tune them. So the result depends much on the artist, designer, architect as on the algorithm itself. Because not everybody plays the piano like Martha Argerich, or writes novels like Mark Twain, but both use instruments in tandem with human mastery. So with that, I'll just want to do a little bit of pitch. We are the Spatial Human Centered AI Research and Experimentation at UF. We focused on how to develop AI implementations that are looking at it as a tool or as an instrument. And as I said, this is it cannot be done by myself alone. We are a group of researchers, innovative thinkers who are thinking about how, if we need AI, how should it be implemented? We looked at AI into two ways. We have AI to empower creativity, which is most of the work that I show you today, but we also have another research area that is called AI for social good. Here is most of my PhD research and current research with public health and disaster response, which is dealing with large data sets and trying to find meaning out of that, and how can we help areas where they have few people but a lot of data to make informed decision making. Future steps, we're still looking at form to text, text to 3D form. We're looking at how to make campus around the US to collaborate for disaster response. We're working with public health and also wanting to talk about vocabulary analysis. So yeah, I want to say thank you, and that's it. I'm 5 minutes more time, but I hope it's worth it.
Don't worry about it. That was an awesome presentation. I think thank you for that. That was great to see. I think from your work, I guess from your research at your for your thesis for PhD and kind of like the trend that we're seeing there, it's very interesting. How do you encode architectural intelligence, whether it's through 3D geometry or through selecting like kind of like these specific features, and then combining them or describing them in a textual way, which is usually pretty hard if you think about it. How do you describe an architectural object in text? So Carla, thank you for that. That was an awesome presentation. And let's talk a little bit now about your background and how you got to where you are now, because you are from Ecuador, so you're Latina. You study in Ecuador, right? And then you went to Europe to do your master's and your PhD. So tell us a little bit about your background and your history.
Sure. As you said, I'm from Ecuador, from Cuenca. I did my undergrad at Universidad de Cuenca. At the time, during my bachelor thesis, I looked at landscape, historical landscape, because I was focusing on historic preservation for some years. And I decided to do a master's degree in landscape architecture. I always liked computers. So that was I think my generation was one of the first generations that got to do all the work digital. So I got fascinated. I was always into digital work and computational, like trying to use computation to solve some of the problems in architectural design. And I saw a master at ETH Zurich that was about landscape architecture, but applied technology. So I thought that was exactly what I wanted to do. I applied for the master's. I got scholarships because it's very expensive to live in Switzerland. But once I was there, I got very much involved into large-scale landscape visualization. So we were working with point cloud models and laser scanning. And one of the things that for me was really interesting is that at the time I could see that every geometry or everything that I draw was data. So the beauty of using algorithms to get into the very specific points or vertex or faces at that time was something that I never ever experienced before. So that was my first intro into coding. This in 2016 so then I decided I want to do large scale exploration through computation. When I'm gonna make like a long story short, so 2016 I was ending my master's, then there was a big earthquake in Ecuador, and I was living in Switzerland at the time, and I felt that I could not do anything by being abroad, and I started thinking that I would like to produce knowledge or produce tools or produce something that can help people in future scenarios, in the same case that I was. So I started writing a proposal for creating a visualization tool that can help community visualize their future by using virtual reality and point cloud models. And that was my initial PhD proposal. So with that, I got accepted to the PhD at ETH Zurich with Professor Ludwig Hofstadt. But as I was moving forward with my idea of data and my fascination of everything can be bytes, bits,
Mhm.
I started changing my question about not only focusing on visualization, but really understanding what is the core that people, what are the data modalities that people need and are produced, and how can we leverage those modalities to create informed decisions. So at the time, my PhD then focused into understanding everything about AI and its use in the different data modalities. So I had several examples of how to use text. For example, at the time when I was doing the PhD, there was so many literature about what to do after a disaster, but it was coming from academia, but it's also coming from humanitarian organizations. And they do talk about similar subjects, but they never overlap. So you will not be able to find them, let's say, someone quoting someone and then using the tools that has been developed in academia. So my first application was to create a common ground where I collected, I think it was like 20,000 academic articles and 10,000 humanitarian organization mission statements. And I created a pool where they bold overlay, and if you have a question, the question will land into a collection, or a group of humanitarian organizations and literature that are all about the same topic. So by that, I was able to write my literature review, looking at the combination or the joinery between these two narratives that happen in disaster. So that's like some work that I did in text, and it's only possible using AI and feature extraction methods. Then my work in generative algorithms, which I presented today, but then I also worked heavily in computer vision, because a lot of the data that you get after a disaster are based on satellite imagery. So how can you retrieve information from satellite images that are meaningful? So for example, one of the first projects that I did is about food security, which is we need to know where food is, especially if you're in areas that the roads are cut. So for us we need to know where the fruit trees are. So at the time we created a classification localization algorithm, which was telling us where the fruit trees are, what type of fruit is, and then we created a optimization route method that will tell us which route you have to take to harvest the most, which route you have to take to be the fastest to the warehouse. And this was one of like explorations that I did that landed into where I am right now. So my PhD is on disaster response, looking at all these different data modalities that got fused eventually. So I was working for a long time how to make a data fusion approach, which now is everywhere. And my fascination with design, because I'm a design studio professor, and I also do like to think about the different applications of AI, is what the Share Lab currently works on. So it's a combination of architects thinking into different questions where AI can be used as a tool or as an instrument.
Yeah. And that's really interesting that you kind of went from landscape architecture to computer vision and then to where you are now. And one of the things that you brought up is the idea of that everything that you get, or like that you're able to get, let's say through computer vision, it's like a digital sort of data point, right? In some sense of the word. How do you see I guess like the encoding of all these things as a way to understand? Because you say you use essentially feature extraction to help you extract like what the articles are talking about, how to pinpoint information in that. How do you see that translate into like 3D, or like in the case of like 3D data?
So one, if you go back to the idea of the intelligent environment, so I think now we should move beyond the 2D representation of space, especially because we live in a 3D world. So how do I see these feature extraction methods through space? Is that, for example, in architecture, you know that there are specific elements like columns and roof and walls that do perform in a different way. So the way that I will encode space right now is by trying to understand how can you encode these specific elements, and then how to create an algorithm that will join them in a way that is meaningful based on all the learning that we have with data. So if I'm looking at, if you look at the final project that we have, this is it's a simple parametric generative algorithm, but because we could set up rules on how these elements are coming together, we could start projecting meaning on them. And I think this is interesting when you think about the difference between AI and human intelligence is that I feel, my feeling is that AI is good at knowing and discovering, because AI has read, has seen, and has listened a lot of different modalities of data, and it's good at discovering what is already there. So discovery is something that they are really good at. So feature extraction, they're extremely good at, because they can discover what is the meaningful, the most synthetic, latent space to one thing. But I think human intelligence right now are about imagination and creativity. So imagining what could be the future if you do such and such thing, and also projecting creativity on top of what is being produced. So I think if you, I do believe that there is a careful, like a warning here into thinking. I do believe that there are some creative work output from a purely machine generated thing, but I do think that creative output is just there because we are projecting what we think is creative there. So we can tell a story, we can really narrate what is seen there, you can talk about it. So I think the idea of projecting creativity on top of a object is what it makes it creative. And I think now, I mean, I maybe like diverge from your initial question, but I just want to make, like, I think one of the things that we have to embrace right now is the idea of storytelling.
Hmm. Yeah, I was just gonna ask you about that because in the plain models title of the presentation, you talk about like storytelling, narrative, and I think we're seeing that like a lot now, at least from my perspective of running the fusion and like seeing all these artists and what they're doing with like text to image models over the last year or so. Usually, it's not necessarily the idea of the prompt itself. It's just how the artist or whoever's like generating these images, how they're generating a story, right? How they're inputting their own sort of bias into like the representation of the image or whatever's coming out, and then curating it, which that goes kind of through like that human filter of like what they feel is like the best. Um, and I like you said, like I think that's a pretty interesting approach. Now, what you're doing with like the 3D part of like joining kind of like text to structures, where structures is like, from my perspective, it's like a very I would say maybe a technical and more rigid approach because it's gonna have to work in some way that is optimized for like physical forces, right? So to be able to describe a structure in some way, but then have it optimized for these physical forces, how did you fuse those two together, or where did that idea come from? To be able to fuse text, narrative, and then like the physical simulation.
Mhm. So this idea, as I said, I collaborate with my friend Pierluigi for many years, and this started with a conversation about the work that we did with Beyond Typologies, Beyond Optimization, and the work that I had with this humanitarian organization, Common
Mm-hmm.
Ground. So we identified that the initial the empirical GAN that we created, which was creating a generator and a discriminator by saying just I prefer and non-prefer, was kind of restricting the way that you talk about in architecture. So when you're talking about your project, you're just not saying I don't prefer this, I don't like it, but you're saying like, oh, I think this one needs a little bit more of this, or I think this one looks like that. So we were thinking, how can we embed some of the current, let's say, projections of what we see on these projects into these structurally stable forms. So it is not very easy because in order for you to label them meaningful, you need to understand the algorithm from, like, you do need to be aware of what are the things that you're looking at. So the colors that you're looking at, some like blue are compression, red are tension, and they already are materialized in a different sense. So compression elements are thicker than tension elements, and if you're looking at them in such, like, you could already, like, I'm not a structural designer,
Mm-hmm.
far from that, but after several years of collaboration, there are some rules that they teach you, like, that you can understand, like, this feels feasible, right? So if there is something that looks twisted, you could already say, or I mean, yes, this could be stable, but I will not see this build. So there is this
Mm-hmm.
previous training that you need to do, which is what I was trying to say here, is that you, I don't think AI, well, I don't believe AI will take our jobs, or I believe that we, or the practice of architecture, is relevant because we are trained to understand space, and we're trained to understand the relationship between things. So what happens if you have an algorithm generating all of these structurally stable forms? Then if you could not describe why this is, this will not work because this, and this, you will end up with a city full of non-relevant or non-well created structures. So what I wanted to say is not an easy job to pair text to a structural tables forms, but it requires a previous knowledge of how you read them. And this is also what we did with Jimmy in our in the last work that I showed very briefly. The idea is that the way you respond meaningful can be complemented by your ways of like not being conscious by looking at things. So you are kind of creating a hierarchy of elements when your eyes and your hand overlap, but you're also creating an aura around, which is saying this could also be part of what you're asking. Because sometimes your eyes, when you ask a question, it really like it starts like looking around, and then it stays on one space and then stays on another space. So I think the idea of trying to capture data in kind of layers of exercises rather than just using one way of capturing data is exciting, because you can overlay them. So you can ask questions, you can ask them to move around, you can ask them to look at them, you can ask them to speak about it. So you can have them many ways. So I think that's the way that you should do it in order to pair structures with text. You should not just use one method. You should try to use kind of a different levels to capture much more detailed data.
And I think something that's interesting there is this overall trend, just in AI research in general, right? Where you now have the combination of multimodal inputs, right? And the idea that like the world is obviously multimodal for humans. So you're going to need computer vision, textual description, or even audio or some other modalities. And now we're kind of moving into like a more fluid, which is like video. Um, what do you think of this trend as it can affect like what you're doing or your work in architecture and like with AI?
Well, I think it's going to be a fun time. Um, I work with my students in design studios to embrace the idea of data. So they get to collect thousands of images, thousands of text. I think the moment like more established tools that will allow an easy handling of data are for videos, then that could already enrich the design process. So for example, I use the data collection approach for user and site analysis, because sometimes like the methods to do so user needs or site analysis are like very structured. So you go there, you start measuring things, and then you take pictures. But what happened if you could try to do the same approach by like collecting a narrative of everybody who's been there and has talked about it? It is richer, and it's not you reading what's there. It's a community telling you this is what we think, this is what we like, this is what do we do in this place. So this is, for example, a very community friendly approach to do user needs analysis and site analysis. And with video, this is interesting because video is I could see this also as part of our data collection and understanding of the site and users, but I could also quickly see this as a communication tool that is indeed much more powerful than images, which now I think now images are almost for free. Images are so easy to create that we need to go back either to, for example, now I am thinking of going back to be very careful with drawings and to push this idea of masterful drawing. Because the moment you have a beautiful drawing, you can always do several iterations into images, and those images can be beautiful as well. But you always need to have a very like an initial beautiful drawing where this can like flourish into different interpretations of the same idea.
And And I guess like the other thing is that if when you do drawings and you translate them to images, in that case, right? You're leveraging like some pre-trained model. Let's say if it's not yours, it's some company's pre-trained model. So there's some inherent bias in that data set, let's say. Now, what do you think about like if you're using it for like architectural, any design sort of approach, the idea of how do I say this? Essentially taking like that pre-trained model and just using it and getting whatever you output, and then not I guess injecting some architectural intelligence, right? Because at the end of the day, we need some sort of architectural intelligence. And I think you're kind of approaching that with like the project that you're doing with Jimmy, like the last main show, where you said you're taking an existing building or 3D space and then using text to edit specific parts out of it. So how do you see, I guess like my question would be is like, how do you see developing methods to capture architectural intelligence as a some sort of encoded representation that we can then use later on for further downstream tasks?
Um, well, this is very interesting. I've seen these materialized into these image generators. I've seen a lot of different new generators that are catered, for example, to generate aerial views, to generate interiors, to generate. And this is a transfer learning that is not very complicated to do. You just need to get, of course, like okay, let me back up a little bit. I do think that now we need to leverage the industry ready algorithms as generic tools, but we should work into making them personalized models. So we should use this transfer learning approach, which means that you do leverage the existing training of millions of images, but you cut the last layers and you add new training data based on what you want it to be learning from right now, and then you create a personalized model. So this has been done in computer vision for already, I will say like maybe like 7 years already. I've seen a lot of work into satellite imagery prediction or detection elements, or natural images as well. But in architecture, a lot of firms have applied this idea of transfer learning to create personalized models in order to create, their brand model. So these will be SOM. This will like all of like these companies are trying to create a branding based on their existing projects, and I think this is probably what it's going to look like in the next 2 to 3 years. Big companies are going to have their trending already personalized, or the brand of the image, or the image of the company is going to be already embedded into these models that have used transfer learning. What I think into what is interesting now from the side of academia or from the side of the small companies is that you can use these tools because they are generic and they're easy and they're free, but you should be thinking about what makes your design process different than anything else. And how can you really create something that it is only possible if you're using the AI? If not, I mean, that's why one of the main questions that I have when I have, so I'm the only AI person in my department. So I do have a lot of people come in and say, hey, Carla, let's do this AI project. And my question always is like, do you really need AI? Could you do this without AI? And if you can do this without AI, why do you need to, why will you try to hustle around this to make this part of your AI just to test? So I'm saying the first question is to look at the existing design processes that you do for design, and then try to identify areas where you think any AI methodology, not only, and I think probably most of my pushback for some time in teaching is I don't allow my students to use generative tools yet. I mean, I use, for example, for structural design, I think this is like far from their final project. So they just like work with the structure, and then they have to come up with a form, and they have to come up with a program. They have to come up with the whole design. And I just constrain this, and at the very 2 weeks or 3 weeks, I like let them loose, and they can use a lot of these image generators to start thinking about interior spaces. So I think like it's very interesting to do interiors with that. And then also about specific lighting studies and some detailings that they can test. And then they have to translate that into their project.
So I guess like to follow up on that, the you mentioned something that is kind of like the idea of novelty, familiarity, and then how you're thinking about like that sort of tail of the normal curve, right? Where and I think like where people seem to be, or at least from my experience, where you tend to use these generator models is like you want to kind of generate something novel, right? Like you're looking for something maybe novel, something that I don't know, like you wouldn't come up that maybe you won't arrive at that point, right? Um, so how do you, I guess, how do you see the use of these models or tools essentially for novelty and familiarity? And how do you approach that as an educator?
Yeah. Well, I think the balance between familiarity and novelty lies into this idea of knowledge and
Hmm.
creativity, or knowledge and imagination, like the same parallels that I'm drawing into, AI can discover, we can create, AI can know, we can imagine. AI can be familiarity and we can be novelty. So that's how I put them into these parallels. Because I think the moment you balance them, you're able to create something that you could consider to be truly creative, or truly you could be proud of the output. If you think of AI pointing to a direction, this is what I was saying, like it could just show you a vector and say, hey, I mean, based on everything I've trained, based on if this is a transfer learning model that is already trained with some of your work, or if this is a generic model, it will show you this is what it's possible, right? It
Hmm.
shows you a direction, or it shows you an area, and you can say, all right, now I know what it looks like for everyone, right? Because this is what everyone will see. Everybody is, if they use a similar prompt to you, won't be the same image, but will have the same atmosphere, right?
Hmm.
Then if you know that this is everybody seeing, how can I go beyond that? Right?
Hmm.
That's the thing of familiarity. You build a familiarity using these tools, so you can do novelty. You use discovery, you use the knowledge that these tools have, so you can create and you can imagine.
Interesting. Yeah, and
But I
because
mean, this is my brain. It's not
yeah,
something.
yeah.
I'm just saying what I think and feel about it.
Yeah. No, I think it makes sense. And it's like it's one of these topics that pops up in like AI like talks where for example Jan LeCun says that, these big models, they're just like big interpolators, right? There's no essentially like extrapolation, maybe to like the to us as humans, since we're not gonna see, I don't know, billions and billions in images during our training. We can let's say interpolate between all these images and form new relationships between existing data sets. But if you want to go like kind of like what they would say, like thinking outside the box, then there's something else that needs to happen. And I think the idea of novelty, that's kind of interesting because I think um, designers, architects, or people that work kind of like more creative mediums, they're always sort of looking for that something new. And it ends up being when you use these tools that it's always the human that has to put that filter, whether or this is novel or not, essentially, right? And then they inject their own sort of meaning, which that comes with the storytelling. And I think you capture that very well in your presentation and like the topics that you talked about. So I guess like now that we're coming up on the hour, Carla, um, what is your um I guess like teaching philosophy for students in this kind of point in time where everybody's looking for like the AI experts to know like should we learn AI now in architecture school? Like what should we be focusing on and what do you think about that?
I think we need to learn well, not AI, but like coding and computation in architectural school. I think
Hmm.
that's something that must be included for some time right now. Like later because I know that there's been a push into elementary school. Like later, all these elementary beautiful kids are going to come to college and they're going to know this. But for
Hmm.
our generations, I think college should have a basic computational and coding class. Not to make us coders or programmers, but just to understand and be coding literate. I think the idea of literacy here is not about us writing code from scratch, just the fact that we can read and understand processes. I think that's what I believe it needs to happen in architectural practice. In my current, like my teaching philosophy is about doing through projects. And that's how I actually learn a lot of my coding and AI applications. I was fascinated. I had a question and it's like went online and found my answers. So now in class is of course you are there and you can guide them and show them like literature to read, you can show them web pages to go. But I think the students that get the most are the students that get fascinated by a project and then just go and do it. At UF, we just created I think I know it's the first AI certificate for graduate students in architecture. So this is an AI in architecture certificate that has four core classes. So there is fundamentals of coding and computation. That's when we like look at the history of computation. And I think that's beautiful as well, because it's not that it's just like came to be right now. This is from early 1600. Like this whole idea of software and data and processes was already in written, and we're just like slowly thinking about this and applying them. And then of course, like how does a code looks like? And that's the fundamentals of coding. Like we start with very simple, like what is the lambda calculus, what is the Turing machines, and then we show examples, what are variables, what are functions, what like all of these very little things. And then at the end of the class, we allow them to use ChatGPT for coding, because now they know how to read. And to
Yeah.
write, we can use all of these agents and all of these assistants to help you. Then we use another class that is AI ethics and biases in architecture. So this is a much more descriptive, argumentative, discursive class, which we talk about what happened. Like the main question is what happened if AI is a known infrastructure? How will the architectural curriculum changes in the first years of architecture? So we go through different modules, and at the very end, the students create a design studio class based on architectural AI as an infrastructure for architectural design. Another one is machine learning for architects. This is a fun class, which is like applying a lot of different AI tools. But they're also teaching them like one of the main things that I like to teach my students is that they can get data, and how powerful you feel when you can get all of these and then start analyzing that. And the fourth class, which is the core, is a design studio. It is a design studio that tries to build a lot of the different classes that you have, but there are some much more advanced generative tools and questions that I'm fascinated about with landscape architecture, which I think there's a need for that. To develop computational design tools for landscape architects. It's very, very few. And I love speaking about large scale projects and landscape. So that's more or less teaching philosophy, a branding of the certificate, and things that our students learn here.
Awesome. And I guess I'm trying to think. Do you like have you had any insights maybe, and this is kind of like a more like the students that you see interacting with what you're teaching them about AI. Have you found any like key insights of like how humans are interacting with this technology? Like is it something where I don't know, is it starting to like do you see students already coming ready, or does it take them a longer time to understand how to some of these concepts work?
They don't come ready. There is a lot of leg work needed, and that's why I'm saying we need to do it. Otherwise,
Yeah.
we're gonna be too late. So I will say very few, probably a lot of the class. My design students were undergrad, so then the kids, the students are open to do it. Sometimes in grad school, you need to be a bit more structured and push a little bit more because they are older and they have established practices. But I'll say I'm pretty sure in other schools you have more students that come on more or less ready, but the ones that I have here, they are all willing to learn, but they don't have
Hmm.
the goals yet.
Yeah. Yeah, that's interesting. Because I think at this point we don't even need to know that much about coding to be able to use these tools. And it's kind of fascinating because I'm sure when you started studying this type of stuff, like AI machine learning, it was way much harder to use some of the tools that now are completely ready available. Um, so that transition over like the last few years has been pretty remarkable.
Yeah.
And Carla, so final words. What is your advice to like aspiring architects, researchers interested in like AI in architecture?
get fascinated by a question and then try to solve it. I think that's what I
Yeah.
have to learn. And I'm fascinated by the work that I do. I don't think I will be this long in this field if I was not fascinated and interested in what I'm talking about. I think that's one of the first things, like fascination, and of course try to I don't I call it scientific, like try to be scientifically like not how can I say, like not trust it blindly. That's what I wanted to say. Like I do believe we need to be conscious of the potentials and the challenges that certain tools have. And I think here what I will say, if you try something, claim responsibility.
Mhm.
Otherwise, if we are not responsible for the work we put out, this is creating a mess for everyone.
Awesome. All right, so we'll close on that. Thank you so much, Carla. We included the links to the Share Lab in the YouTube description. So if anybody's interested in that, they can always check it out there. Thank you so much for this. This was really interesting. I thought it was kind of insightful to see different ways just to encode different modalities into geometry, which is something that like I always thought it was like a very hard topic, especially when you're trying to come up with descriptions to describe geometries in architecture. It seems that architects have a way of expressing themselves when they're designing. And sometimes that is a very thing to capture into like some sort of 3D object. So I'm really impressed by your work. Thank you again. Wish the best of luck, and I hope to see more of your work in the Share Lab and see where you guys go.
Thank you. Thank you for the invitation. I had a lot of fun. Well, if anybody is interested, I'm always up for collaborations. I do love people. I'm intrinsically positive. We will have fun.
Yeah, awesome. All right. So thank you, Carla, and enjoy the rest of your weekend.
You, ciao.
Ciao.